One particular type of enthalpy value that is commonly tabulated and is really useful for calculating others is the enthalpy of formation, or the standard enthalpy of formation. And this is the enthalpy for a reaction where you form a chemical from its standard forms, its standard elemental forms. This is given the symbol delta FH naught. So the naught, this is the standard part. And what that means is that we have 1 mole of the product, and all reactants and products are at their standard states. And we'll see this degree symbol several times throughout this class. And so we should just go ahead and define it now. And what we mean by things in their standard states is sort of like what under 1 bar atmosphere, 1 bar pressure, I should say, what's its usual condition that it has. The formation means that we have a formation reaction, formation from the elemental forms and the standard elemental forms. So let's do some examples just to make this clear what I mean by that. So if we have, say, for example, methane in gas form, what would be the formation reaction for this? Well, we would take 1 mole of carbon, and we need the standard form of it, so that'd be solid, and even more specifically, it's going to be graphite, which is its standard form at 1 bar of pressure. And then we add hydrogen, but not atomic hydrogen, we add hydrogen dihydrogen, its normal form of hydrogen at standard conditions. And this would be the formation reaction. Maybe we have something a little bit more complicated, like methanol. Still, we would have our carbon. We would have our hydrogen. And we would have 1/2 of an oxygen molecule. We don't just use atomic oxygen, we use 1/2 of O2 because O2 is the standard form. And so that goes to CH3OH, liquid. Right. And so you can find tabulated values in table 19.2 in your textbook. One reason why why we bother going to all the trouble of tabulating these is that we can find any delta H value for any reaction if we know the enthalpies of formation of the reactants and products. So let's imagine a generic reaction where here we have A moles of A plus B moles of B going to Y moles of Y plus Z moles of Z. Right, so now a generic reaction. So we have our reactants, right, A moles of A, B moles of B, and we're interested in the process where these go to the products. Y, make that a lowercase y moles of Y, Z moles of Z. And maybe we don't know a lot about this process. What we can imagine here is that we can imagine an alternate two-step process, and because enthalpy is a state function, it doesn't matter if we actually go through this process. This is all theoretical. We break everything down to its elemental forms. And then in step 2, we rebuild them into the products that we have. And so if we, the enthalpies of formation are going to tell us how much heat it takes, what's the enthalpy it takes to get to the elemental forms, and then we can use the enthalpy of formation of the products to figure out what's the enthalpy it takes to get back to the products from the elements. So doing step 1 and step 2 gets us the exact same answer as if we go through the other process and we get the same final reaction. So what we can write is, in general, delta H for our reaction, for this generic reaction we have, is going to be Y moles of Y times the enthalpy of formation of molecule Y plus Z, the stoichiometric factor for Z, times the enthalpy formation of molecule Z. And so that's our products minus our reactants. So A, the stoichiometric factor for reactant A, times the enthalpy formation of A minus B times enthalpy of formation for reactant B. And in general, we can say that's the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation for the reactants with the appropriate stoichiometric coefficients that are there. One final note, just by definition, we need to define sort of a zero. And the zero we define is that the enthalpy of formation for elements in their standard states is defined as 0. So that's sort of our 0 that we set. So for example, H2 gas has an enthalpy of formation of 0. We could say the same thing for carbon in its graphite form, oxygen, other things, right? These are our reference point that gives us, everything else, everything's relative. Things that are not in their standard states, even if they're elemental forms, will not have an enthalpy of formation of 0. For example, if we have diamond instead of graphite, the enthalpy of formation for this is slightly non-zero. So it's positive 1.897 kilojoules per mole. So enthalpies of formation, there's a nice table in your textbook, and you can find it in other places. Trying to find the right table. I have it here in my notes somewhere. Table 19.2. There we go. So if you want to find these in your textbook. And that's it for chapter 19 on the first law.